Hey, good afternoon, and welcome to today's webinar on secure development with Microsoft 365 and Azure Active Directory. Let me just do some quick intros. Peter Carson here. I'll be your presenter this afternoon, president of Extranet User Manager and also an Office Apps and Services Microsoft MVP. Contact details are all here. We're going to be sharing the deck and the recording after the call, so you can pull those all from there. Love to continue the conversation if anybody would like to from that perspective. I'll go fairly briefly on the background side of things. Extranet User Manager, security is obviously a big part of what we do. The product is all about bringing people in from outside of your organization, and obviously you want to do that securely. We've got a number of flavors to that, whether we act as an identity provider that we'll talk more about in a minute, or whether we leverage on top of Azure Active Directory, which is going to be the primary topic for today's talks. I've been doing this for a lot of different years. It's evolved over the years. It started very much as a SharePoint on-premises solution, turned into a cloud-hosted solution, and brought in Azure Active Directory and Office 365 support over the last 6-7 years or so. Clients around North America, primarily Canada, the US, but a bunch in Europe and elsewhere around the world as well. So quick agenda, we've done the introductions. I'm going to start with a little background, just some security fun facts and things to think about that I think are relevant to the discussion today. We'll get into a little background on Azure Active Directory itself as well. User objects, application objects, service principals, which are names you may or may not be familiar with of the various entities in Azure Active Directory that we're going to be referring to. We're going to spend a fair bit of time around authentication flows. This is a big part of the topic here, is as you're building your applications, and I'm going to use a variety of different scenarios from PowerShell running in Azure Automation to SharePoint Framework web parts to full-on custom web solutions as examples for different authentication flows as we go through here. I'm going to kind of intersperse with that some talks around attack vectors and best practices, some sort of current news around SolarWinds and things that are happening out there right now, and also obviously touch on permissioning, and then not so much specific to security, but very connected to it is the issue of throttling, because decisions you make from a security point of view have an impact on the architecture from a throttling perspective when you're talking to Microsoft 365, particularly SharePoint Online. That's going to be the main context of what we're going to be talking about here. Before we start, we've got a quick fun little poll for people to go through here. So either pull your camera out to a quick camera of the QR code. Don't actually take a picture of it, just hold it up and you should get a pop-up for the link, or you can use the bit.ly link down at the bottom to go ahead and fill that in. Gives us a little background and context for the attendees, so always appreciate that. Okay, I'm going to pause here for a second and just switch my view to turn my camera off. Probably don't want to look at my smiling mug the whole time here. It gives a little more screen real estate to see the main topic of interest, which is the slides as well as the demos. We're going to be doing a fair bit of into the Azure portal and looking at things from that perspective as well. So Azure Active Directory is really the basis for all things security in the Microsoft cloud, and for a lot of organizations it comes off of what's in your on-premises Active Directory. So most small or mid-sized enterprise organizations still have an on-premise Active Directory. I mean, you can be a cloud-only organization and strictly have everything in Azure Active Directory. We're actually in the process of moving that way ourselves. I mean, we've still got a couple of servers that we're maintaining for client development environments, but otherwise we've completely moved into the cloud. We don't have any on-premise production servers at all anymore. And we recently did a device migration as well, so we got new Surface Laptop 3s for all of our staff, recognizing that post-COVID people will be coming back to the office, but probably not full-time. So let's figure out this hybrid working environment now, and all those devices are Azure Active Directory joined rather than domain joined. So we're kind of in the process of moving completely into the cloud from that point of view. I don't think our on-premises AD is going to disappear. There's going to be a need for those sort of on-premise SharePoint servers and such we use from a development point of view, but it's a pretty minimal footprint at this point. In fact, those servers themselves are all in the cloud too. They're virtual machines. Even our domain controllers are up in Azure now. We've got one physical machine left on premise, and I actually like to get rid of that one as well. But the idea is if you've got an on-premise AD, you want to sync that with your cloud Azure Active Directory. Not just your users, but your groups, your devices, everything that exists in your on-premises AD. And Azure AD Connect is the free tool from Microsoft that does that. You deploy it onto one or more servers. From a high availability point of view, you typically want to have it on at least 2 servers. And it basically runs in your on-premise environment, and it pushes all your Active Directory information up into the cloud, into your Azure AD. That can then get consumed by Office 365, obviously. You can leverage it for your own applications. You can leverage it for third party as well. Azure AD allows federation with a whole bunch of different services, so that works really well from that perspective. And then your users can sign in with their devices, authenticate against Azure Active Directory. I'm going to beat this one a fair bit. We're going to want to see things like multi-factor authentication turned on the sign-on here, and that actually influences some decisions you need to make from an architecture point of view as well when you're building out your apps that we're going to touch on. Now, I didn't realize this until I started researching for this talk, that there's actually 2 versions of Azure AD Connect. There's the traditional one that's been around for quite a number of years now, and there's a new one that just came out this year called Azure AD Connect Cloud Sync. And basically what it is most of the work happens in the cloud rather than on-premise. There's still a lightweight agent because it still needs to connect to your on-premise Active Directory, but all the work happens up in the cloud, as opposed to most of the work happening on-premise with the traditional Azure AD Connect. Under the hood of Azure AD Connect, there's actually a SQL database that's provisioned as part of that, running within that Azure AD Connect. So it's a fairly heavy footprint you need on these servers here. In fact, we're still running Azure AD Connect on that one on-premise server that we have left, only because we didn't want to pay for a big enough VM in Azure to keep running 724 to run Azure AD Connect up in the cloud from that point of view, because it does require a decent amount of hardware. I think we have a 8 gig machine that it's running on-premise, which isn't huge, but it's not tiny either. I mean, it would still cost just a couple $100 a month in Azure VM cost to host that in the cloud. Whereas we could say, okay, let's just put a lightweight agent. Doesn't even have to be on premises. I mean, we have domain controllers in the cloud that are much smaller, more lightweight than the server we have on premise, because just acting as a DC doesn't require a lot of resources, and the subscription costs for those are pretty minimal. So I'm going to actually start looking at this to say, hey, can we get rid of our on-premise AD Connect and go to the cloud sync and run that lightweight agent? It also has some advantages. If you've gone through an M&A activity, maybe you've got multiple organizations that you haven't formally merged yet. Maybe you've got disconnected Active Directory forests across those different organizations, but you're pulling them together under one 365 scenario. It's a common scenario. We're actually going through a cloud migration right now with one of our clients. We just did another one a couple months ago where they'd been acquired and they're now coming into the parent 365 subscription. We need to move everything across from that point of view. Through that transition period, Connect Cloud Sync could do that synchronization across those disconnected forests. What it can't do, though, is it can't sync things like custom AD attributes. It doesn't support pass-through authentication. There's some filtering and write-backs that it doesn't support. So you have to kind of weigh the balance there. But for us, as an 18-person organization, I mean, we're not doing anything fancy from this point of view. The Cloud Sync could work really well. And even things like custom AD attributes, I mean, those typically come from things like your HRIS or ERP systems that you have on premise. Maybe you want to push employee data up into Active Directory, which is a really good idea. You could modify those processes and say, okay, let's push those attributes straight up in Azure Active Directory and not have them part of the Connect Sync process. So again, architectural decisions you can make on how you want to structure that out. So this is where I'm going to flip a bit into some of the attack vector stuff. This is actually from a talk given by Microsoft just before COVID. It was actually the end of February of 2020. I used it on some talks I did around security just as the lockdown was starting and everybody was kind of going whole hard into the cloud. Some things to think about from a security point of view. And there was some interesting / scary stats that Microsoft shared from this. And one of those was just the number of compromised accounts in Azure Active Directory, and this looks like a super frightening number. 1.2 million is a very large number. You got to remember there's billions and billions and billions of Active Directory accounts. This is across all tenants in all geographies, so it's still a percentage of a percentage kind of number here, but it's not an insignificant number. And what they did was they shared some details behind that, and they said, okay, what contributed to that? Well, 99.9% of those compromised accounts didn't have MFA turned on. I mean, this is the single most important thing to do from a security point of view. It's not from a secure development perspective, so it's not directly part of our talk here, but it actually influences decisions that we're going to make. You want to make sure that every account in your organization has MFA turned on, and I'll talk in a minute about things like service accounts that aren't proper service principals, that are really just user accounts, and the temptation to turn MFA off on those so you can use them with backend processes, it's a really bad idea, and I'll explain why and what you can do about that. If we look at what contributed to this, about 40% of those compromises were done through what's called password spray. Basically, you harvest dark web troves of compromised passwords from past data breaches globally, and just start throwing them into accounts to see what happened. In fact, this was a major component of the SolarWinds hack that happened last year through the beginning of this year that's still very topical. It was lit up in the news the last couple of days as congressional hearings continue on that, and lots of discussion around that. So, having MFA turned on kills that password spray attack. So that's a very important thing from that perspective. The other thing is that those password spray attacks typically use what's called legacy authentication. So it's a style of Azure AD authentication to support legacy applications. And really what you want to do is turn on conditional access policies. It doesn't require Azure Active Directory Plan 1 or Plan 2 to do that. You basically block the legacy authentications, or maybe you've got some rules that say, hey, and we still haven't mitigated some of these old apps and we still need to run them, but we're going to use them in a very contained environment, so that if they connect from a on-premise domain connected computer in certain scenarios, we'll let it go through while we mitigate. But really your goal should be to eliminate all of those legacy apps, and even things like older versions of Outlook are one of the dominant ones here. So making sure that you're current on your Office desktop and your applications in general is a prerequisite to doing this. Again, so we had 40% from password spray, 40% through replay, and the legacy attacks primarily used. Replay attacks primarily used legacy auth as part of that. So those two things, MFA and conditional access policies to deal with legacy authentication, super important. So this is a note from Microsoft Docs here, sort of a top 10 list of things to do from a security best practices. I haven't gone back to double check. This was one that I used from last March, so it's about a year now. I think all of it pretty much still applies from this point of view. And like I've already said, I'm going to beat the dead horse, but setting up MFA is super important. I strongly agree with number two being number two, which is training is so much of this as well. Phishing attacks are a huge part of this, and you can put things in place, to protect email from phishing attacks and malicious attachments and things like that. But the first line of defense is actually your users, just educating them on what to be aware of, when a suspicious link shouldn't be clicked on, and things from that point of view. Number three is actually super important too, using dedicated cloud-only admin accounts. So, domain admin accounts were actually one of the prime attack vectors for the SolarWinds attack, and that was sort of their first entry into the system that they then went laterally from there. So minimizing and protecting those domain admin accounts and not tying those to your cloud admin accounts, having those as separate, and making sure that you've got MFA against both of those. In fact, things like having a conditional access policy that enforces MFA on every single authentication for admin accounts is important. Having notifications around odd behavior against that. Having an emergency break glass account that you can use if you mess up things like conditional access policies and lock yourself out as an admin. So there's a number of things you should be doing from that point of view. I won't get into all these in this talk, but I just want to make you aware of some of those things from that perspective. But let's come back to the Azure Active Directory side. So I mentioned at the beginning this concept of user objects, application objects, and service principals. And these are important concepts to understand as a developer when you're using Azure Active Directory as your authentication scheme in your apps. So, we've done this in the past. We've been guilty of it as well, that we'd often use user credentials in integration scenarios, and we would try and be smart about that. We'd store those credentials into an Azure Key Vault. But the problem is that MFA would break that, and going to a client and saying, hey, can you turn MFA off on these user accounts, doesn't fly anymore. With a CSO, that's a big red flag. You don't want to have MFA turned off on anything. The problem was that there was a lot of things that we couldn't do with service principals, and we needed user credentials. That story's gotten better. Microsoft has deprecated, for example, the older style PnP libraries that are used for accessing 365, and they have a PnP core library that they just released at the beginning of this year. It was kind of funny because when they deprecated the old one, a lot of that had to do with security issues. They said stop using this, but the new one was still in preview. It actually wasn't general availability. I think that's been rectified now, but it is a bit of a moving target from that point of view. So, this idea of disabling MFA on service accounts is a big security hole. You want to avoid that. So what service principals are is they're basically application registrations that you've registered an application, not a user, that's going to need to have certain access into your 365. And authentication is done in a different way. It's either done with a client ID and a secret, or a client ID and a certificate. And our preferred approach is to use a certificate. I'm going to take you through some authentication flows so you get your head around what that looks like. And Microsoft's already built a lot of support in for this. The Azure App Services, so we'll often build server-side web applications, C# Visual Studio type of projects that we run in Azure App Services. They're a great way to host that. It's basically virtual machines. You don't manage the VMs. You just say, I want this many nodes on this side, and Microsoft takes care of patching them and making them available. And if any of them go down, they just spin up another one from there. There's service level agreements and high level availability all managed for you as part of that. And part of what it does is it actually manages the certificates for you as well. So I'll show you what that looks like. Azure Automation is another big example for us. We're creating, say, PowerShell scripts that we want to run on a regular basis. In fact, I'm going to use our team's provisioning scenario that we've done a lot of work on and we've open sourced out. I'm going to use that as an example where we have run as accounts under Azure Automation, and Microsoft actually manages the certificates in the Azure application registration as part of that process. And under the hood, both of those, there's a private Azure Key Vault. Key Vault is a service from Microsoft for keeping secrets like this secure. And later in the talk, I'll talk about standard versus premium and some things around hardware security models and such that you can use to even up the game further from a security point of view there. Okay, so pictures always work better. So let's give you a picture to show you a bit more of what the application object and service principles idea looks like. So when you go into Azure Active Directory and you register an application, and I'll show you in the Azure portal in a minute what that looks like, you're creating what's called an application object in the home tenant that application is registered in. And then when you apply roles or permissions to that application, what you're doing is actually instantiating a service principal, and that may exist in the same tenant that the application is registered in, or it could be in a different tenant. So a single application may have different permissions and roles assigned to it in different tenants. So these resources that it's using don't have to be the same across these subscriptions. And each time you instantiate that in another tenant, you're creating another service principal. And it's that service principal is the object that the authentication is happening against as part of that. So let's actually flip over to the Azure Active Directory portal here. So if I come to my Azure portal and I go into Azure AD and I look at my app registrations, sorry, I just gotta find the right one here. So here's my team's provisioning application. So it has a client ID associated to it. So that's part of the identification. I almost think of that like a user principal name. It's a unique ID that exists in this tenant for this application. So if I go into that particular application, that's part of the authentication required for that. So you need to know that client ID. The other thing that you need to know is a certificate associated with that. So here we've uploaded a particular certificate, and there's actually two sides to this. You have to create what's called a public and a private key pair certificate. The private key you keep locally within your application in a secure spot, typically in Azure Key Vault, and the public key you upload into the application. So that's what we're seeing here has been uploaded in there. And the way the authentication works is that the calling application, or sorry, this application here that needs to do the authentication will call into Azure Active Directory with a token signed by its private certificate, and that token will be authenticated with its public key here in Azure Active Directory. So your private key signed token needs to match the public key that unencrypts that up in Azure Active Directory. And then both sides know that they trust each other and things are working from that point of view. Makes these certificates really important. That's why using things like Key Vault is so important, because you don't want to lose control of those certificates. And I'll talk about how that was sort of a second stage in the SolarWinds attack, and things like golden SAML and golden ticket approaches that were used as part of that. But let's come back to the diagrams and the pictures. I just want to take you through an example here. So we're going to keep focused on the Teams provisioning scenario for a minute here. And the way that solution is built is that it's running in Azure Automation. And like Azure App Services, this is kind of like a serverless environment where you've got a virtual machine that gets grabbed from a pool, and your runbook, your PowerShell code runs in that. So you don't have to maintain that server. Microsoft maintains that for you. You don't even pay $7.24 for that server. You get a certain number of minutes per month as part of your subscription, and then you pay a very minimal amount of dollars above and beyond that for additional consumption minutes that you use there. And part of what that Azure Automation account provides is what's called a run as service principle. And this is basically an application, like I was just showing you, that's registered in Azure Active Directory, and its certificate is automatically provisioned for you and stored in a private key vault. You don't actually see this key vault, it's underneath the hood. But when your runbook needs to talk to, say, SharePoint Online over here, actually I got the wrong label on there, that should just be SharePoint Online. Basically what it does is the PNP module from Microsoft, so that new PNP core stuff that I was talking about, has a bunch of middleware already in it. So you don't have to do a lot of the heavy lifting yourself. Basically, in your script, you call a PNP connect commandlet, and you pass it a client ID. You don't actually pass it the cert. You don't need to touch the cert yourself. What you enter in is the thumbprint of the certificate. And then this code here takes care of getting that out of the key vault and passing it over to Azure Active Directory. Azure AD can look at that and say, hey, I recognize that client ID, and this token is properly signed because I have the public key cert that matches this private key. Everything's good. I can pass back that it's valid and give you a token back. What you can then do is use that token to call a service that you have permissions to. In this example here, to SharePoint, and we're calling in this example to sorry, not a logic app there. We're actually doing things in SharePoint and in Teams as part of this. So when this endpoint here gets that token, it needs to do a validation. And again, there's a bunch of middleware that Microsoft provides that talks to Azure AD and does that same validation of that certificate to say, hey, is it properly signed? Do I trust it? Is everything good from that point of view? Then it can say, okay, yeah, we're good to proceed, do its work, and return its response back from there. So let's actually have a look at that in the Azure AD portal. So let's come back here, and let's go into the resource group for the Teams provisioning. So we've got a bunch of resources in here. And actually what I'm going to do is I'm going to take you through the, actually no, we're going to start on the runbook side. I'm going to come back to the logic app side in a minute, sorry. Okay, so we've got this create site runbook here, and it has some scripts in it that creates SharePoint team sites and teams and provisions a whole bunch of stuff, sets up templates and tabs in your teams and things like that. So it needs access into various different services in 365 in order to do that. So if we look at the automation account itself, so when I create a new automation account, one of the questions I answer as I'm creating that is, do I want a run as account created as part of that? I don't necessarily have to have that, but in this case, we've said yes, let's go ahead and turn that on. And we can see here, we've got an Azure run as account. It says expires April 9th, 2022. It's a 1-year expiry, not on the account, but on the certificate that's been used to authenticate that. So if I click into that run as account, we'll see we've got a display name for it. We've got this thumbprint, which is the important piece of information that we need to pass from an authentication point of view. We've got an application ID, which is the app registration. So what I can do is I can copy this application ID. And if I open a new tab here and come back into my Azure Active Directory, let's go back into my app registrations. I'll go to all application. I just paste that client ID in. Then I know for sure, okay, I'm coming to that run as account. So that display name that we're seeing here is the same name that we saw up here. So we can see that there's a certificate with a thumbprint. Again, that matches the thumbprint that we have over here. Now, if I'd done this manually, I could upload new certificates and manage my certs through here. Because this was done through Azure Automation, it actually takes care of that for me. We'll see back here, there's actually a renew certificate. It'll go through and create a private public key and update the Azure Key Vault on the Run As account, and also the registration up in Azure AD. So it makes it much simpler for you from that point of view. Okay. Now, we also need to assign certain permissions to this Run As account to decide what it's allowed to do. And I'm going to go deeper into this in a minute, but basically we've got the ability to do full control of all site collections in SharePoint, because we're going to create new sites as part of this. We're going to create new teams. Teams have Azure Active Directory groups and members underneath them, so we need the group create and read write and member read write as part of that. And we actually do some templating around OneNotes as well. So we want to be able to pin the OneNote tab into the channel tabs and teams. So we want to be able to access the OneNote notebooks as part of that. So you need to decide what's your script's going to do and what sort of roles and permissions does it need as part of that. So as I said, we'll come back in more detail on that and have a look at that. Okay, so this is kind of just what I walked you through there. It gives you the steps to follow in terms of doing that. So if you haven't used Azure Automation in your Azure subscription before, basically you need to create an Azure Automation account first. And if you want to use this authentication style, you're going to want to leave that Run As account set to yes. Once it's provisioned, you can go to the Run As account, get the application ID, which is the client ID as I showed you, copy that, go over to your app registrations in Azure AD, search for that client ID, and then you can bring up that application registration. Then whatever API permissions you need to assign, you can go ahead and assign those and then start building out your runbooks. So for things like PNP, which is Microsoft's open source patterns and practices that we use a lot for a lot of our 365 integration work, they've got an out-of-the-box here to connect to PNP Online that lets us connect to SharePoint. There's similar ones for Azure AD, for Teams that we use as well. And basically what we're doing is we're getting the connection name. So by default, it's called Azure Run As Connection. You can have multiple Run As connections defined in your automation if you want. And basically we're getting that service principal. So we're getting that local tenant instance of that registered Azure AD application through this get automation connection. And then what we do is we pass the tenant ID, the client ID or application ID, and the certificate thumbprint, which are all properties of that service principal, to this connect PNP Online. PNP knows how to use that to say, okay, I'm going to go talk to Azure AD against that tenant with this application ID, and I'm going to pass across that certificate that's in the local private key vault and go through this whole top left part of the authentication for you. And basically at that point, you've got a token that you can use to call the service that you want to call. And that's basically how all the 365 services work. They accept a bearer token that you've gotten back from Azure AD. You need to pass that as part of your header to your calls, and that's what authenticates you to the applications. I'll talk more about it a little bit later with the SolarWinds stuff. I mean, what happened there was they didn't do it in Azure Active Directory. This was all on premises, but basically they used password spray to get to domain admin accounts to capture the private keys that were stored for signing these tokens. So they didn't steal the private key of these certs here. They sort of stole the golden ticket key at the top level here, so they could generate their own tokens and call any service as anybody asking to do anything. So it was a very, very highly elevated permission that they had at that point that they could then use to do all sorts of nefarious things from that perspective. So protecting that certificate is really important. That's why doing things like keeping it in Azure Automation and letting Azure Automation and Key Vault manage that cert for you is a really good idea. Now, not to say you can't do this locally, and what I found, and we're still working through some of the rough edges on the Teams provisioning using the new PnP core stuff from Microsoft, was that we need to actually test locally using the same certificate authentication. You know, the PnP commandlets work differently if you give them user credentials than if you give them service principal credentials. So you really need to test it the way that you're going to be running it in the cloud in Azure Automation. It's why you can get lots of debugging information, you know, log output from Azure Automation. You can't set breakpoints and step through your code. So I like to be able to run locally in PowerShell ISE environment, set breakpoints, walk through the code, see what's going on from that point of view. So you basically do the same sort of thing, but instead of using a run as account, you register your own application in Azure AD. And you either have to obtain a certificate or create a self-signed certificate. And this docs link down here actually includes the PowerShell to create your own self-signed certificate. And there's nothing risky about having a self-signed certificate in this scenario, because nothing is validating up the certificate chain like you have on an SSL website. What's important is that you properly protect the public and private keys to that. So you upload the public key certificate, the .cer file, up into Azure AD as part of that app registration. So if you remember when I was back over here in my application, this is where you would upload that certificate. And then you install the private key certificate in your personal store. So if I bring up MMC, Microsoft Management Console, for a minute here. So I just did it was on my other monitor, a start run MMC to launch this. And then what I want to do is come to add, remove snap-in, come to my certificates, say add, and I want to do it from my user account, because when I'm running PowerShell locally, it's going to be running in my context, not in my computer account's context. So I just hit finish on that and OK. If I come down into my personal certificates under the current user, you can see I've got a couple here that I used for local development. Like here's my Teams provisioning certificate for that. So it is a self-signed certificate. That's why it's giving me this warning saying it's not trusted. That's actually fine from this point of view. So I've right-clicked and imported the certificate through here, and that was the SPFx half, or the private key half of the certificate. And then I put the CER, the public key side of it, up into Azure AD. And then I can basically run this same style of code, except I don't have a service principal anymore, but I do have a tenant ID, an application ID, and I can see the certificate thumbprint. In fact, if I come back in here and look at the details on that certificate, you can do this for any certificate, you'll see there is the thumbprint for it. So I need that information. I pass that to PnP, and PnP knows to go into my local certificate store, because I'm running locally, and pull that out and do the authentication from that point of view. Now it is important to use the new PnP, so if you're still using the SharePoint PnP PowerShell Online module, I recommend you remove that from your system, import the new PnP PowerShell, and start using that going forward. There is changes. Some of the commandlets actually change names and change parameters between the two. There's some tooling that Microsoft has around how you transition your scripts from the old PnP to the new. Not in this link here. This is more around how you do the app only and create the self-signed cert. If you do a little bit of Googling, you should be able to find that detail in there as well. Okay, so I've made mention a number of times on the SolarWinds hack. If you haven't been following the news on that, it's definitely a top news thing. Even in the last few days, Microsoft was getting dragged across the coals a little bit as part of this. I mean, it was a very sophisticated attack. One of the estimates put it at 1,000 hackers working together, state-sponsored, you know, pretty much looking like Russia at this point. Biden administration just put sanctions against a bunch of top Russian officials over the last couple of days against that. So there's a whole tit for tat going on from that point of view. So this is sort of the, you know, not your typical cyber attack that you see, but something you should still be thinking about. You know, it affected a lot of top level US federal agencies and a lot of non-government organizations. And And basically, it was what's called a supply chain hack. So the hackers first targeted SolarWinds, which is a technology vendor, and they actually injected malware into their products. And their products are in the security and monitoring space itself. So they're highly trusted products, which then got deployed in up to 18,000 customers through standard updates with those malicious code and vulnerabilities inside of them. So that was pretty nasty. And you know, the whole attack spanned about a year. They spent a lot of time covering their tracks and you know, changing their patterns. So it was very difficult to see that somebody was in there from that point of view. As I mentioned in the beginning, password spray was a big part of the beginning, because the things like the golden SAML attack. So this was an interesting one. Microsoft originally said that you know, their systems weren't used as part of any of the attacks, and then they came back in the last couple of days and said, yeah, about 15% of the compromises happened through SAML authentication using Active Directory Federation services. So older style on-premise ADFS, which is what the golden SAML is all about. Basically, what the attackers did was got those on-premise domain admin accounts, use that to steal the SAML private key certificate. That's why these certificates are so important to treat with care. And they could then create forged SAML tokens. SAML tokens are different than the bearer tokens used for Azure Active Directory, but the concept is the same, and the attack model could be used in a similar kind of way. It's obviously harder to just steal the keys at the gate of Azure Active Directory, but you could steal the private certificate of an application, for example, and impersonate that application. So it wouldn't be a wide open do anything, but it would still give some pretty elevated rights from that point of view. You know, and things like MFA and password change on the golden SAML attack don't have any impact, because you know, all of that authentication happens after it's assumed that the user's gone through their authentication already. So it's too late for things like changing your password to have an impact on that. You know, and they can be used to attack any federated system. And really the key is the control of that private key certificate. So not to freak out people too much, but you know, just I want to make you aware of, you know, the big bad world that we live in and things that we need to be looking out for from that perspective. So some of my best practices from a certificate management point of view, you know, it's super important to store those certs in a secure location. We'll talk in a minute about permissions, and they tend to be highly elevated permissions that you apply to these applications. So treat them accordingly. Just like an admin account, you know, they need to be protected. You might want to consider a premium hardware security module, protected keys, which is part of the premium features of Azure Key Vault. Things like key rotation can be done to you know, at least minimize the duration of an exposure. You know, in the SolarWinds, we're talking about almost 12 months from initial entry through to discovery. That's a really long time to have hackers roaming through your systems. And you know, the challenge that all these organizations are facing now is, okay, we've eliminated the original attack, but how much other malware got distributed through our systems while the keys to the kingdom were open? You know, and that's a pretty scary place to be in. So I just showed you how to create a local certificate to do development work. Please don't do that for production purposes. You know, have a separate sandbox, a development environment. Actually, my next talk, the week after next, is around software development lifecycle and how best to structure, you know, development, test, production environments and things like that. So just use it from your development point of view. Now, if you do lose control of a certificate, part of the beauty is that you can immediately remove it. So if I was to come in here and delete this certificate, doesn't matter who has that stolen private key, half of that cert, it's useless at that point because it's no longer registered in Azure AD and it's shut down from that point of view. So it is nice from that perspective that you can revoke it very easily from that point of view. And that's part of the point of certificate rotation is to make sure that the time that certificate is of value is shortened from that perspective. Sort of continuing on the doom and gloom theme, the other concept you've probably heard quite often is this idea of zero trust security design. You know, and the main construct of it is never trust, always verify. The idea is that, you know, there is no protected environment. There's no saying, oh, we're inside the corporate firewall, I can trust all the other systems. Never trust them, always verify them. And one of the biggest ones from that point of view is the browser itself. You know, the code that's running in a browser is inherently untrusted. I don't care if it's on a domain managed computer and it's your preferred browser and things are locked down and everything else. You can just hit F12 and go into developer toolbar and start manipulating anything in there from that perspective. You can change code paths, mess around with variables, and even things like secrets, shared access signatures that we're going to see in a minute in logic apps are not secret. You can immediately see them just through the network tab on developer toolbar, and there's not a lot you can do to stop that from happening. Also, you may have business rules that you've implemented. It's fine to enforce business rules in JavaScript from a user experience point of view, but back to the zero trust, never trust, always verify. APIs shouldn't trust their callers. Did those business rules get tampered with in the browser before it got submitted to your back end? You should assume so, and you should verify all of your parameters as part of that. Also, do you know who's calling you? Having that as a parameter in your API itself is inherently risky. Again, somebody could spoof somebody different. Maybe you've got a highly privileged form. Hey, if I'm the CEO, I could just submit an expense form of up to $50,000 and nobody approves it, and they just cut me a check, and I just change who I am, and suddenly that expense check goes to me. It's probably not a real example, but nevertheless, you shouldn't trust even who they say they are. You need to do that in a validated way. And those access tokens that I was talking about embody who that token is for, whether that's a user or a service principal. They're the best way to validate those callers. So, kind of reiterating, the browsers are untrusted. Any of your secure code needs to run in a controlled environment. Could be Azure Automation, Logic Apps, app services, on-premises servers, but not in the client's browser. The other thing, if we were playing a drinking game, Logan would probably be doing a shot right now because he laughs every time I say security through obscurity. The unfortunate thing is we often see it. Hiding is not equal to security. Things like hiding a list, hiding SharePoint columns, even hiding SharePoint as a whole and providing a front-end app that accesses it is not securing your application. There's some lesser evils that we've done ourselves in the past. We want a list where people can submit things to, but it's private information and we don't want other people to see it. So maybe we have a workflow that triggers as soon as somebody submits it, it moves it into a more secure list that people don't have general access to. I mean, there's a moment of time there that it is still available. That workflow may take 30, 60 seconds to run to move that to a more secure location. It's still not an ideal scenario. And you can do things like permissions only to items you've created. That gets a little convoluted. So there's different ways of doing security through obscurity. The bottom line is please don't do it. Make sure that your app is solid and robust from that perspective. We're going to talk more about some of those scenarios. So I mentioned don't trust the browser. The browser, the code running there, you can't trust that it does what you designed it to do, that somebody hasn't been messing with it from that perspective. So typically I would say take your business rules that need to be hard and fast enforced, any of your security secrets, things like that, that should all be in a back-end process. And in the past, we'd fire up Visual Studio, write an API and have a REST interface for that our client-side code could talk to. More recently, we've been actually doing a lot with Logic Apps and Power Automate around this. You can actually expose a Logic app like an API. You can have a REST endpoint to it. By default, it's a post, but you can make it a get, put, patch, delete, whatever you want. And basically you can do a REST call to that, and now you've got secure server-side code running those things from that point of view. But the beauty is it's a no-code solution. You don't actually need to write C# code. You can connect boxes in a Logic app to pull that together. Now, the way by default Logic Apps and Power Automate or Flow secures that is they put what's called a shared access signature secret into the URL. So let's actually flip over to our Azure portal again for a minute here. So we've got a couple of Logic apps that we use for the Teams provisioning solution. And the top level one is this create site submit form. Actually, this is probably a good time to do a live demo through. So let's start on the SharePoint side. We've got a SharePoint framework web part here to request a new team. I'm just going to refresh, make sure everything's up to date. And I'm going to use a temporary demos division, and we're going to create a modern team site, and we're going to call it webinar-4. That one's available. Yep. We'll actually do a live check to see if that alias and site URL is available. We have a bunch of options here. Yeah, we're going to create a team. We're going to do the OneNote stuff, or we'll leave the planner off. We'll leave the defaults for an external sharing. The solution actually lets you customize what shows in this form and set the defaults however you want from that point of view. Let's go ahead and submit it. Oh, and I meant to turn developer toolbar on there. Let me do one more test here because I want to actually take you through that process. So I'm going to get it queued to go. We'll be creative. We'll call this one webinar 5. And I hit F12 on my keyboard. Let me actually undock the developer toolbar. So if you haven't used developer toolbar, it's a super powerful thing to work with. You can see all the source of what's running in your browser. You can go into the elements in there. The thing I want to use in this example is the network tab. What I want to do is preserve the log. So as pages change, I want to hang on to what's in the log there, and I'm going to clear this out. So I'm all queued and ready for my test here. I've got all my fields filled in. I just go ahead and submit on that. When we come back to our developer toolbar, we can see what actually happened through here. And this is the important one here, where it actually did an invoke call. And you can see when I hover over there, it's kind of small, apologies, but it's calling out to Prod 08 Canada Central logic.azure.com. So that's a Logic App endpoint. So the SharePoint Framework web part has taken the form fields that I filled in and submitted it to a Logic App. And like I said, you know, if there was a secret in there, like a signature, I'd be able to see that right through developer toolbar. We actually don't do that, and I'll show you why and how we've done that. So if I come back to here, this is actually the Logic App that got submitted. So you can see it's actually running both. So that was the webinar 4 that I did first, and then this was the webinar 5. So if I go ahead and open up this Logic App. So this is the initial post that came from the SharePoint Framework web part, and I can actually see all the data that was filled in the form. Yeah, I want to create a OneNote. I don't want to create a planner. I do want to create the team. You know, all the details that I filled in through that web part are available to me here. Now, I'm actually going to open a second tab here because I want to show you design as well as run mode as we go through here. So if I hit edit on here, and I look at this when an HTTP request is received. So this post URL that comes in, I can copy that. Let me actually put it in a notepad so that you can see it. So this last part of the parameter here is that shared access secret. It's a signature. It's a unique string of letters and numbers that you need to know to be able to call this post endpoint. Problem is, if we did that in the example I just showed you, I could go into developer toolbar, I would see that signature, and I could start throwing whatever I wanted at this this workflow. And I wouldn't know who was sending it. It would just be basically an anonymous post at that point. So what we wanted to do was actually set up authorization on this. So we've registered an application in Azure AD, and we've actually put the client ID of that application as an authorization policy. And what that's saying is that you need to call with a token from this application to be able to call to this Logic App. If you don't do that, it's going to deny it. You're just going to get a 403 and access denied coming back from that. So it's a way to secure it, and it's not something you see through a developer toolbar. It's not sort of a permanent secret. It's through that handshake. So let's actually come back to our deck and go through what that looks like. So a similar diagram to what we saw previously. Actually, this was the one I started with, so I forgot to rename some of these things when I did the previous diagram. But we're in this SharePoint Framework web part where I was selecting the team that I wanted to request. And before that can submit to the Logic App, it needs to get a bearer token from Azure Active Directory. SPFx actually has a bunch of this plumbing in here. So I request with a client ID, and SPFx middleware knows how to actually get the certificate and registration and validate that with Azure AD and give me back a valid bearer token to use in my call to the Logic App. Logic App, again, there's some middleware that happens before it even gets into my Logic App that validates that token, make sure that it's properly signed and everything's kosher from that point of view. And once it comes back from there, that's where my Logic App starts running from. Now we do some additional validation that I'm going to show you in a minute in there, and then we do the work, and we return the response back to the SharePoint framework web part. So let's have a look at what that looks like. So if I come back in here, actually I'm going to go back to my running instance. Where were we here? Too many tabs going on. Okay, so we got our initial request. Yeah, we set up some variables that we want to use, and we actually call out to another logic app that I'll show you in a minute to validate that bearer token. So we take the token that was already checked for certificate signing, everything's kosher from that point of view, and we pass it across to this logic app to pull out some information that we want from that. And what we get back from that, if we come down a few steps, we parse this user JSON, is all the data that's inside that bearer token. You know, what's the audience that it's for, what's the application ID that it comes from, in this case, the user principal information, you know, what's my given name, my family name, what IP address was I coming from. But the important part is this user principal name. This is basically your username in Azure Active Directory. It's your unique principal name across the tenant that identifies who you are. And the thing is, I can trust this name. It was validated through that certificate, through the token, through Azure Active Directory. That all came back to me. It's not a parameter that was provided to this endpoint. So back to that zero trust concept. I'm not trusting it. I'm going back to Azure Active Directory to say, who called me? Here's a token they gave me. You told me it was a valid token, but I want to know more about it. Show me those details through there. And we're going to actually publish these logic apps as part of the next version of the Teams provisioning. Let me just pop this open into a new tab here. And if I go into that, where are we? Validate bearer token. It's a bit of an misnomer. I named it improperly when I first created it because it's not actually doing the validation. The middleware does that for you. What it's doing is actually parsing that bearer token, saying, okay, I got the bearer token passed to me. It's got a particular schema to it, and I'm going to parse what came through. So that I'm going to take that schema and parse that out. And there's some base64 data in there that contains all those properties that I was showing you on the other side. So we basically want to pull that out, you know, decode that base64 data in a couple different ways. So there's a number of cases. Dinesh, who's my director of development, figured all this stuff out for me. He did a great job. Basically different scenarios of you know, no 1 or 2 padding coming through as part of that base64 string. What does it need to do as part of that? Parse it out appropriately and then pass that decoded user string back to the caller logic app. This particular project is a nice example of some modularization on logic apps as well. So we've got the original submit form logic app. It calls this validate bearer token. And then when it's done, it may go through an approval process. It may not. And then it calls out to this provision site logic app to actually build out the site. So if we look at that one there, we can see that it ran at 1244 and 1245. Those are my 2 runs. And what it's doing is it's getting the data that came in, which actually all got stored into a SharePoint list, so we can do the approvals if they're required and such through that. And it basically gets the information about that site that we've requested. So there's my demo webinar 5 site that I asked for with all of its details. And it basically comes down here, says, yeah, it's approved. Do I need to do something for that? And ultimately what it's going to do is call out to Azure Automation and actually create that team and that site as part of that. So the previous scenario that I took you through with the Azure Automation is actually part of this solution as well. We're actually calling out to that Azure Automation. In fact, if I come back here and I go to my create site runbook, which is my PowerShell under Azure Automation, again, we can see those same run times. That's the run that just ran for that list item ID. It's still got some grief on. Let's see if it worked or not. No, we've, you know, what happens is because we're using a service principal to provision the team site, it can't assign an owner to it. We do some code to set the owner in Azure Active Directory, but I think there's some timing issues in there that there's a lot of weird back-end sync processes happening when you're creating teams and team sites and such. It takes a little tweaking to get those proper, so we're still working through that detail on it. But it gives you a sense of how that all hangs together. Okay. I know I'm getting close on time here. I probably need to skim through the next few pieces here. I mean, the next example is actually fairly similar to the one that I was just showing you before, but instead of a SharePoint Framework web part, we've actually built a standalone client-side app. And it may have an app service or an API behind it. So we want to do Azure AD authentication between the client-side app and the Azure App Service, and then the Azure App Service needs to do work against things like SharePoint Online. It's going to need its own app registration and token to call to SharePoint Online. So I didn't put all the flows in here, but there's a flow between the client-side app and the app service, and then there's another one through SharePoint. And again, we're using that underlying private key vault underneath the app service to store those credentials. So I do want to talk about permissions. I touched briefly on it when we were looking at the app registration for the team's provisioning, but there's some details as you get into this. So if I come back to the Azure portal here for a minute, and I look at my API permissions, so we've got some existing permissions here, but what if I want to add new permissions? Some of the apps have direct permissions to them. More and more is moving towards using the graph, like all of our SharePoint stuff we do through the graph, all the teams we do through that. And as you come into graph, you've got a choice of, it's called delegated or application permissions. And the difference is delegated, you're running in the context of a signed in user who's calling your app, whereas application permissions, you're working just with a service principal. And there's some differences you need to be aware of as part of that. So if we're looking at a delegated permission, we actually need a user token. And the only way to get a user token is through an interactive application. So it's typically only applies to interactive applications. Like if we go back a couple of slides to this flow here, I mean, this is an interactive application that can sign into Azure AD, and it can get a user token that can be used for delegated tokens in this scenario. Now, you apply permissions to the app registration, but the user also needs their permissions, and it's a least permission applied. So, you know, the user has to have certain permissions and the app has to have certain permissions to be able to do something for that. And the challenge is some APIs only support delegated permissions. I'm doing a talk later in May on rolling up planner data into Power BI, and we built some PowerShell to harvest that data. You know, it can only be done through delegated permissions. We've got to do some tricks to hang on to a token for a long period of time that I'll talk to if we have time in the session here. But the application permission runs in the context of the application. So it only has its own permissions. They tend to be very broad. Like sites full control all gives you access to every single site collection in your tenant. Things like scoping that down is something that's in preview in Azure Active Directory, but it's not fully rolled out yet from that point of view. So these are very privileged rights that you have as part of that. Now, something else to think about is that throttling comes into this too. So throttling is when you make too many requests to 365. Microsoft wants to prevent overuse. It is a shared multi-tenant environment. They don't want one noisy tenant negatively impacting all their other customers. So they'll start sending back 429, which is a too many request, or a 503, a server is busy. And when they give you a 429 error code back for your call, they actually give you a recommendation to say, hey, wait 2 minutes before you try it again. If you ignore those, it's only going to get worse. They're going to start blocking you more. Excuse me. And you may get to the situation where they block your entire tenant, which is a really bad thing. It locks everything down on you. So there's some recommendations, you know, decorating your traffic. There's some guidelines in here on things you do in your REST calls to explain your application, and really respect those retry recommendations. The important thing is when you're looking at delegated versus app permissions is that, you know, most people think of throttling as a user thing, and it is based on requests per user per second. There isn't a defined SLA. Microsoft won't tell you what the number is because it changes. You know, it depends on how much everybody else is using SharePoint at that moment in time. They want to make sure it's as high as possible that's appropriate for that particular point in time. And when you do a delegated app request, it's just like a user request. So if you have 300 users going through your delegated app, as far as SharePoint's concerned, 300 users are accessing SharePoint, and they'll spread those requests across those users. But if you use an app permission, that app looks like one user to SharePoint. So if you have all 300 users going through that, it's like 300 people working as one as far as SharePoint is concerned. So your probability of being throttled goes up significantly. There's different thresholds, also not defined, but it's going to be a challenge from that point of view. What we did on one of our projects was we actually put in a pool of app registrations that we store in a SQL database. So what happens is, we've got this large enterprise application. It's got an Angular front end to it, a C# API running as an app service in Azure, talking to SharePoint. We don't want people to come straight to SharePoint, so we've restricted the user permission so they can't update things directly in SharePoint. They have to come through the app, which means we have to use app-only permissions to get to SharePoint. What we do is in SQL, we keep a table of app registrations, and as we spin up more nodes for our server-side component, because it's a scalable environment, we start using more app registrations, which spreads the load from a throttling point of view on SharePoint. Actually worked really well. We did some performance testing, which I know you're not supposed to do. Microsoft doesn't like you doing that, but we needed to see that we actually hit throttling and that the solution scaled across app registrations and prevented that throttling, and that all hung together and worked as designed. So it was nice to see from that point of view. Couple of last slides. I know we're at the top of the hour. Some important things to think about. I mentioned that those Azure Automation Run As certificates need to be renewed annually. There aren't notifications around that. You can use things like application insights and put some monitoring, and I'm sure to look for that. Likewise, Logic App itself. We didn't get into the API connections inside of the Logic Apps, but those need to be periodically reauthorized as well. And those are not service principals. They are more of a user account, although they could be sort of a dummy service account as part of that as well. The reauthorize is an interactive action, so you don't have to turn off MFA, but you do need to go through that. And I haven't seen notifications saying that authorization is expired. It's more that your Logic App starts failing because of that. So it's something to be aware of from that perspective. Just to wrap up, got a part 2 webinar coming up the week after next, which is all about software development lifecycle. So, how do you take not just these secure development approaches, but general development in a 365 world and manage a dev test production type of environment using Azure DevOps and pipelines and continuous integration and all that goodness. So stay tuned for that. And then I mentioned the planner boards roll-up Power BI dashboard session that I'm doing May 20th. It uses some of the topics that we talked about here today. So apologies for going a little accelerated at the end there. There's a lot of content there. Hope that was useful to you. Be safe out there. Think about secure development at every step of the process, and want to thank everybody for joining me today. Have a great rest of your day.